Today's topic, Vernier calipers. So it is an instrument, right? So you can see up in the animation, it is an instrument. Why we use it? This instrument we use, a small definition is given from the Google, right? It's a precision instrument used to measure the length, depth, thickness. Of course, see how to use this instrument. Let's see first. Then we will come back to the topic. So if you see this instrument, you can there are two scales you can see. This scale is called as main scale. The normal scale it appear like that. It's a main scale. So you will get main scale division as well as there is a movable scale that is called Vernier scale. There are two scales like main scale. For example, I kept some pen here, like I adjusted here the pen, right, and I fitted this. Then there are two readings you need to get. One is main scale, how much it is, see 0, 0 0.1, 0 0.2. Then Vernier scale started. So main scale, how much it is, 0 0.2, right? So first reading you will get main scale reading, main scale reading, correct, is equal to, let it be in this case 0 0.2. Now Vernier scale reading. How to take Vernier scale divisions? Vernier scale divisions, you just observe where there is an exact coincidence with the main scale and the Vernier scale lines. See, divisions. These two not match, not coincident, not coincident, not coincident. Here also not, here also not, here also not, here you see. This seventh one, this seventh division is exactly coincide. This is 6, this is 7. So you have to take 7. So now we got Vernier scale divisions are how many? 7. Now what is the final reading? The observed reading, the reading is you have to add these two, right? Main scale reading directly you can take plus least count into Vernier scale reading. Vernier scale divisions. Vernier scale divisions are 7, main scale reading 0 0.2, and now you have to find out the least count. Okay, let's talk about this least count for some time. So what is this least count? Least count is the least possible value you can measure with the Vernier caliper. So if some in question they ask you error not given, this is the minimum error possible in the experiment. In the experiment. So it is the least value you can measure. It is the least value you can measure. Chalo. What is the formula for this? That is important. Least count formula is 1 main scale division minus 1 Vernier scale division. That difference you have to take. This is the main formula of the least count. So mostly the main scale divisions are given. How much is the main scale division? Each value they will give you. Vernier scale they won't give you. So how to get it? Now they will in question. If for example m main scale divisions are coincide with the n Vernier scale divisions, like how many main scale divisions are there, how many Vernier scale divisions are there, like you can show here how many main scale divisions are there, 0 1 2 3, you can count here up to 1. In how many Vernier scale divisions are there, you can check it, right? In here 10 there, here 9, see 9 main scale divisions are coincide with the 10. So that data will be given to you. Then I want one Vernier scale division, let this value be x, cross multiply. So x into n Vernier scale division is equal to 1 into m main scale divisions, 1 into VSD, right? 1 into VSD. This VSD cancel. So what you got? 1 V, this x is 1 VSD, right? X is equal to m by n MSD. So that you put here. So least count, one more formula, 1 main scale division minus m by n main scale divisions. So MSD you take common. So least count is equal to main scale division into 1 minus m by n, where m is number of main scale divisions, where n is number of Vernier scale divisions, what they get coincide in the given. So this value will be given to you. So first step you find out the least count, that is the minimum error, and that's the least value you can measure. Then put it here, then you will get the reading, exact reading. So in this way we will take the reading of the any measurement if error not there. If error is not given, if error is given, then let's find out. Okay. Now let's talk about the error. Let's talk about the error. Zero error. Open the animation. Now here you see this is 0 and this, both the zeros are coincide exactly. Zeros are coincide. If you put here, now it is movable, right? I kept at 0, 0th position, nothing is there now. Both zeros are exactly coincide. But this will be not the case in the physical equipment. So in the physical equipment, what we will do, just you see, I will show you the error. Now see, they didn't coincide. But are not coincide. Now you take it and put it at the 0 position, they didn't coincide. This position is called as 0th error. And where is my Vernier scale? Vernier scale 0 is the right side of the main scale. That I will write it. Now I want 0 error. In the case number 1, my Vernier scale is right side, and that is called as positive error. Why I called as positive error? See, because it is giving you already some value. Now I want to put pen here back. So you got this reading, you got some extra reading, because you see it is already showing some value. That extra reading you have to remove. Now correct reading will be, now the correct reading will be, you already found the reading here, this is the reading, correct? So that reading value already you have to find out that minus positive error, means this 0 error you write minus the 0 error. So in this way we will remove the error and we will get the exact correct value even the equipment is error. Now is this the only case? No, there is second case possible, that is negative error. Now Vernier scale will go left side, will show you the animation, that is called negative error. Now what we will do, see first animation we will see. This is the case positive error, right? Now we'll animate it. Say now you see Vernier scale is at the left hand side of, Vernier scale 0 is the left side of the main scale 0. Now it became left side. Here right side there, now left side there. This is called negative error. Why I called as negative error? Now you will understand. Now if you want, I want to put something, some paper I want to put, I kept here, let it be. Here I kept some thick sheet. Now if you see the measurement, it is exactly 0. Now is this the reading is 0? No. Reading is 0, but error is there. That error you should add to your reading. Then you will get the value. That's why we will add here. So now the correct reading, what it became? Now the correct reading became your found reading. Already you found the reading plus 0 error you do. Okay, plus 0 error. So in this way you will get the exact values with the Vernier calipers. Here why we added? Because this value it is not giving, you see, when I kept here, we kept some sheet here, but reading is 0, but actually it is not 0, right? It is the thickness is not 0, there is some thickness is there, that we are not getting because of the 0 error, that is negative 0 error, that you have to add to your correct reading. Hope you understand. Thank you. Vernier calipers, one vernier scale division is smaller than one main scale division. Absolutely correct. That's why vernier scale is used for higher precision to calculate the smaller values. So this is true, undoubtedly. Next, the vernier constant is given by one main scale division multiplied with the number of main vernier scale divisions. No, it is wrong. There is no multiplication. Least count is one main scale division minus one vernier scale division. Okay. Screw gauge. Let's see the instrument animation. Here is a screw gauge. There are again two scales are there like vernier scale. Now you see this is, if you rotate, you can rotate it to the clockwise or anti-clockwise. You see here are the readings. Now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 readings are there. Then each 0.5. Chalo, otherwise one you can take it. Each division on the main scale is 0.5. You have again main scale. This is main scale. What you can see, and this is circular scale. What it is rotating. You see there are 0, 1, 2, 3, 4, 5. There are circular scale there and main scale there. Again there are two scales there like vernier scale. Same. So you will get again two readings. Main scale reading. So your final reading will be like vernier scale. Main scale reading as it is you take plus least count into vernier, here not vernier scale, it is circular scale, right? Circular scale divisions. Now this is main scale, you can rotate it. You can rotate. So here you can fit anything like pen, paper, thickness of what you want to measure, that you can fit it here and you can rotate this. So actually you can rotate from this last edge, if you can rotate it from here. And say I fitted here something. So now I want to take the reading. Let's take the reading here 0.5, 1, 2, 3, 0.5, 1, 1.5. Main scale reading how much? 1.5 it is in this example. In this example, main scale reading is 1.5 and circular scale divisions you want. So what, how many number of C? This is 35, 30, 31, 32, 33, 34th division coincide with this line. So you have to take circular scale divisions 34. Now basically you want least count to get the answer. Correct. Let's talk about least count. This is the main formula. Talk about least count. Least count is the least value you can, it is possible to you to calculate, right? So I will make it 0. So I'll, what is the least rotation you can do? You can rotate just one division on the circular scale. See, I rotated just one division on the circular scale, and you see here there is a small gap there. You can put some paper in it. So this is the thickness of the paper you can measure. So least count is one circular scale division. If it is given, that is your least count. If it is not given, so how do you get one circular scale division? I'll do one thing. I'll just rotate it for one time. Complete one time I rotate it. See, if you rotate for one time, exactly if you rotate for one time, see one division on the main scale it is appears. So I can say one main scale reading, one main scale division reading, one main scale reading, just one reading, that is 0.5 in our case, divided by n number of divisions on the circular scale. You see, total how many circular, how many divisions are there? 45, 46, 40, 50 there. 50 rotations I made for getting one main scale reading. That gives you one circular scale. Both are same actually. If it is given, use it. If it is not given, main scale given, then main scale reading divided by number of circular scale divisions. What is n here? N is total number of, here total number of circular scale divisions. Circular scale divisions. Total how many given you check. This one main scale reading we call it as pitch. Pitch divided by n. So this is the most important formula for least count. So once you get the least count, okay, once you get the least count, you can do it. You can just substitute here, you'll get the answer. This is without zero error. Now we will include error if given. See, errors you will include if errors are given in the question. There are again two types of errors we already know. Positive error, positive zero error. So here when you will get positive zero error. See, positive zero error means you should see zero errors you can include, right? So this is without error. Now I made it as I made it as to the, you can see 0, right? Right, perfect. Now here you see how many divisions. Now your circular, your circular scale 0 is below the main scale 0. Here is the main scale 0 and here is the circular scale 0. Circular scale 0 is below. You are getting some extra value. Can you see some extra value in the main scale? Yes. That extra value is the error that you should rid of. That you need to remove it. That is called positive error. Here, circular scale 0 is below the main scale 0. That is called positive error. Sir, how to find out the error? Same formula like Vernier scale. Error is equal to least count into circular scale divisions. How many circular scale divisions? Right now, how many there in this case? It is 8 divisions there, 5, 6, 7, 8. 8th division is matching. So least count into 8 you do. Then what is the correct value? Correct value will be, correct reading is equal to reading minus positive error. Minus positive error. So you will get the exact answer. Now, okay. Now there is case 1. This is case 1, right? Positive error is the case 1. Now case 2 possibility there. Yes. What is that? Now circular scale was below. Now it will move above, you see. Now you see circular scale 0 is above. Now it is closed, more closed. Now this is called negative error. Negative 0 error. Circular scale 0 is above. Again formula same, error is equal to least count into circular scale divisions. Then correct reading is equal to your reading, what you used the formula. Already you found the reading plus negative error. Plus negative error. Let's see why we do plus in the instrument. Now this is the error. Already we have this instrument, we have error instrument. Now I want to put something, I need to open it. I opened it. It is opened, you see. Now I kept some paper here. It is showing 0, but it has some thickness, right? Why it is showing 0? Because error. That error's value you should include. That's why we add it. Hope you understand. Thank you so much. The length of the rectangular sheet is measured from the screw gauge. Okay. Length is measured with the screw gauge. Pitch is given, screw gauge pitch is given, and number of divisions on the circular scale is given. Maximum possible error in the area. Okay. See, basic area formula, rectangle L into B. See, length also, breadth also, they measured with the screw gauge. Possible error is, what is the error possible? Least count. So first of all, find least count. Least count formula, pitch given, right? So pitch by number of circular scale divisions. Pitch value 0.75 mm, answer is in mm only, by 15. Chalo. We can cancel here. So you can write it as simply 75 by 100 into 15. 15 table 5 times. So it is simply 0.05 mm is the least count. Once you get the least count, now you see length given, breadth given. Possible error they are asking. Area is equal to L into B. Okay. So you take this value. Area is equal to L into B. Relative error will be same. So delta A by A, if you take the relative error in the area, it is the relative error in the length plus relative error in the breadth. So we want delta A. Area formula L into B, find out this value. L value 5, B value 2.5. 25 5s are 125, 1 point there, 1 point you put here. It is mm square. So we know this value 12.5. That is equal to delta L value. What is the possible error? Least count. So this error is 0.05 by length given, right, 5, because the possible error is least count. So the error in the length can be 0.05. The error in the breadth can be 0.05. Least count. By breadth given, how much? 2.5. So calculate this value, you will get the answer. See, 2.5, 25 table. 2.5 one times, 2.5 two times, 5, 5. This is 5 times. You can cancel 2.5. 2.5 one time, 2.5 two times, 2.5 5 times. So what you got? This value is into 5 will come, right? This value is 0.025, division you do, plus 0.05 is equal to this value will be 0.075. This is delta A by 5. 5 you transpose. So what it becomes? Delta A will be 5 times of 0.075. So this will be 0.55 is 25, 2, 35, 37, 3. 0.375 mm square is the area error possible. Thank you.